is, well, instead of just rewriting it, that is also equal to I sub r, I sub c, I sub l, and there's 4 from right there. Okay.
Is there an order you like to do these? Like, is there a reason you did the current next, or could we have done the resistance or the voltage?
I did power supply first because I had the maximum value, I had epsilon sub naught. I don't have VC, VL, or VR.
Or VR,
Yeah.
okay, gotcha. That makes sense.
So ultimately, VR, VL, VC. We still need those. We also need the phase here. All right, so we've exploited Z as much as we can. So I'm about to erase all the impedance stuff over here. Any questions before I erase? We'll still need X sub C and X sub L, but all right. At this point, we still need to sort of start picking stuff out here. I thought for my right triangle here. I know my hypotenuse is epsilon sub naught, which is 141.4. I know that this is VR, and this is VC minus VL. That's a right angle there. I need to figure out what that angle is. I need to figure out some angle. I need to figure out this angle right there. Those are the same value. Well, let's do it. I'm going to label this cleverly phi sub 1. I know the tangent of phi sub 1 is, what is tangent again?
It's gonna be our V sub C minus V sub, L, sorry, wait, multiplied by, divided by V sub R.
Okay. I don't know the V's, so what can I do? How can I simplify this sum?
C minus L over R. Well, we don't know that, never mind, that doesn't make any sense.
Would it make sense to use like a sine inverse or a cosine, just so that you can use the number that's known? Is that
Yeah,
what you're
except
advised to do?
we would still have 2 unknowns. So
Yeah, that's true.
now there probably is more than one way of doing it. You might go that route, so you have those 2 unknowns and then work it from there. But there is a simple step that we can take next in order to be able to use this. Because I don't know V's, but I do know something else.
We know our current, right?
Yes,
It's the same.
we do.
Yeah, sure.
And what's the relationship between each of these and the current?
The relationship over here.
So this becomes I x sub c minus I x sub L over I times R. My i's cancel out. And so I end up with my phase here being the arctan of xc minus xl over R. Now, I've got it written this way because of the way I originally wrote my phasor diagram. If you blindly follow the calculator, you're going to run into an issue. So let's go ahead and blindly follow the calculator and then figure out what the issue is. Because I know XC, XL, and R.
Make sure your calculator's in degree mode.
What? And not radians?
Right, because we're finding the degree of phi.
Well,
Do you want
ultimately, I need to know what it, I would like to know what it is in radians, but if you're in degree mode,
Yeah,
we'll
I'll
stick with that for right now.
At least you thought about it. I was just going
Still listen to
straight
the
arrow.
arrow, yeah,
That is not the issue, though,
It's a good
that we're going to run into.
yeah, I figured it'd be a little more complex.
I didn't
negative,
I have -0.33 radians. Is anyone else getting that?
Yes, that's what I have as well.
'Cause
Alright.
This is the first number I've gotten that was correct all class, so.
Yeah, and I want you to know that if we didn't find whose calculator that was, I want to donate it to you.
That's very
Just so
thoughtful.
you know. I just would like that for the record.
and now that you know whose it is, do you still wanna donate it to Anna?
Yeah, let's steal it from Freddie.
Wow, cool.
Alright,
I'd fail if I tried to go through an exam with that calculator
Yeah.
right now.
it is a negative here because I arbitrarily made VC longer than VL, but since they're both proportional to the same current in this particular problem, we can know from at this point that I should have made VL longer. So epsilon sub naught actually is a first quadrant. And so you do need to be careful about that because VL is bigger than VC, so you'd have, that difference right there would now be up here, epsilon sub naught is there.
So if we run into that, we should just flip the VCVL in formula and then have the right answer?
Yes,
Should be
let's
the
be careful
positive.
about that though, because now we have this angle here of 0.33 radians, which would be the same angle there. The question is, for my current, what is the phase? It's either plus 0.33 or minus 0.33.
Right, I'm gonna backtrack a bit. If V sub L was smaller than V sub C, then would we have gotten a positive answer? And would it?
You would have gotten a positive answer, yes.
And would we have needed to flip it to be negative?
No, probably not.
Okay, so it's always gonna be in the first quadrant, the phasor,
No, not always.
okay.
I mean, I could have
Just-
made this,
Yeah.
if I dropped that in half, this would have gotten dropped in half, and XC would have been bigger than XL.
I mean, it makes sense if you're drawing, like initially when you're drawing them, if they're the same length, then the sum of those three vectors was this way,
Right.
right? So when we altered the problem, we just flipped which of the numbers was bigger. So it won't always be in the first quadrant.
Yeah, that makes sense. I guess I just don't understand why. We just have to pay attention to which vector is bigger.
Yes,
Like, okay.
yeah, which I did not because I started out with no numbers. All right, so does the current from the power supply lead the voltage from the power supply or lag? Which comes first?
For the power supply?
Yeah,
Um,
knowing that epsilon sub naught really is here, and my current is here.
So the current is lagging in that case.
Minus 0.33.
Did we Eli the Iceman that? Or is that just?
It's just the way, that's the nature, it comes from the VL is bigger than VC, and given the numbers in the problem.
Could you explain all of that again?
Alright, so the way I've drawn it right here, I have the current is ahead of the voltage.
Mm-hmm.
So if that is the case, if I had drawn it correctly, this would have been, the current would have been ahead of here, because there's an implied plus 0 here. So if the current led, then it would be plus, it would be something above 0. The phase would be bigger than 0. That's not a look of one of recognition here. All right.
Yeah, I'm still trying to just conceptualize it as if the current was.
Yes, and
Right.
All right, so I got my two phasors right here.
Mm-hmm.
So this one, middle finger pointing towards, in the direction that originally drew my power supply
Yeah,
voltage. And they're going around like this.
yeah,
So current is in the lead
yeah.
and will stay in the lead, like the same amount the entire time. So as they are moving around like that, this angle right here would tell me how much that the current is ahead, if this were drawn correctly.
Okay.
But I didn't draw it correctly because ultimately we ended up with XL bigger than XC, which means VL is bigger than VC.
In VC, okay.
So now this actually should be up here.
Yeah,
So middle finger still towards the voltage power supply,
uh-huh,
and so it's leading
it's leading.
by that angle right there, just the absolute value of that angle, 0.33 radians, that angle.
Yep,
So since my power supply is behind it, that's indicated by the phase, by how much, this is how much it's behind.
So because
the
it's
power
behind it.
supplies,
because the power supply is behind it, that's why it's negative.
Because the current's behind the power supply,
Or
that's
because
why
the
it's
current-
negative.
Okay,
Okay,
yeah.
because the current, okay. Yeah.
If the current was leading the power supply, then it'd be positive?
Yes,
The current was-
And if they were in phase, it'd be zero.
correct.
Ah.
So right off the bat, I know that the current and the voltage for the resistor are in phase, so this would also be minus 0.33. Matter of fact, at this point, since I know where the power supply is, sorry, try that one again. Since I know what the phase of the current for the power supply is, I can now get for the inductor and the capacitor. Because that's my actual epsilon sub naught. I know that's 0.33. I can figure that out. What would this angle here be? Because this tells me how much VL is in front of my power supply voltage,
It's gonna be 0.5 minus 0.33 radians, right?
not 0.5,
Would it be pi minus 0.33 radians?
not that,
Pi
Did I-
over-
did I miss a
pi
word?
over- Pi over 2 minus 0.33.
Okay,
Right,
yes.
there it is. Right. It's that thing you gotta start with the whole and then do the fraction and then do the other piece. Yeah, it helps.
Yeah.
or negative 0.33 plus pi over 2, because this is
Because they're already off.
pi over 2 up ahead of this.
I mean, if your brain works like that. This is complex enough.
Mine does not, yeah.
All right.
This is kinda like if you need to know like the letter of the alphabet, you like say the whole alphabet, it's the equivalent of that.
Yeah, because I have to start with the whole unit circle and be like, okay, the whole thing is 2 pi.
Right.
So then half of 2 pi is 1 pi, and then a quarter is.
You just get faster.
That's
I'm thinking of 7 plus 5 or 8 plus 5. That was the one that messed with me, that I just got faster and faster being able to break 5 up. Anyway. So what is that phase between VL and epsilon? You laid out what needed to be done, if someone would be kind enough to actually do it.
1.24.
And for the capacitor, what is its phase?
Is it going to be,
Pi plus 0.23, but negative. Not pi, half of pi.
All right, so pi over
Pi over
2,
2
but V,
plus 0.33, but it's the negative version of that, right?
yeah, or negative 0.33 minus pi over 2.
Right, right.
Yeah.
because it ends up positive.
That makes
Oh, yeah,
sense.
that makes sense.
Right.
1.90 something?
Oh, wait, what's,
Oh, minus.
Sorry, it threw me because it came out negative, but that makes sense. Negative 1.24.
Ooh.
Not right? 0.33 minus pi over 2?
Negative 0.33 minus pi over 2. Because we're looking to find that angle right there.
Right.
So we've got the 0.33 plus an additional 90 degrees, or pi over 2 radians.
I got 0.91.
You know what?
0.91.
0.91?
The shortcuts are working.
Yes.
That
I
does-
like tried following your shortcut, but it didn't work.
Yeah,
The way that
totally
makes
threw me.
sense for me to do it is like, hold on.
It's
Which one
adding
is
them
it?
together and then making the whole thing negative.
Right,
Think
so
of it.
0.33 plus pi over 2.
Okay, so that came out to be 1.9, which we know is negative, so it's minus 1.9. Zero.
Here, okay.
Oh wait, I had that.
Yeah.
I just thought I did it wrong.
We appreciate your shortcut offers, but we decline them politely.
Could you use a positive number for that? Like, take what we had and then add another pi to it, would that still work?
Oh, take what we had here?
Rather than minus 1.9,
Yeah, yeah.
add 4.4?
Yes, you can.
Okay.
Matter of fact, when you're doing the lab quest in the lab for the phase, sometimes it does that, so you need to be careful sometimes.
Wait,
Sometimes you need to subtract 2 pi in order to make it look better.
what did you do, Zach?
Well, because we had the 0.33 minus up there, right? So we added pi over 2 to that to get 1.24, so I added another pi to go. and get
Okay.
180
Yeah.
degrees.
That's what makes sense to me, I was gonna ask why
Oh,
you just do
yeah.
that.
You did that too.
But that doesn't get you negative 1.9, does it?
But they're the same.
No, get you a
But they
positive, I guess you said 4 point something?
Yeah,
Yeah,
4.4.
So that works too. You
That,
agree?
yeah, that works too.
Okay, cause that made sense in my head, cause I'm thinking, I'm still going counterclockwise instead of negative and, or
Okay.
clockwise instead of.
That's fine, nothing wrong. My mind wasn't working that way.
Seems like you want us to put the units for a lot of the other pieces of this formula, but we're not writing radians, is that intentional? Is that just like implied?
Yeah, when you're doing an angle and you don't write any units, it's radians. Radians can be dropped or added whenever it's convenient.
Unlike other units?
Correct. Because radians ultimately are unitless.
Oh,
If you flash back to the small angle approximation, when we said that if the angle is small in radians, we can say the sine of the angle is roughly equal to the angle. That only works if the angle has no units, which is radians.
oh, yeah, okay, I do remember that.
Alright. So we're still missing this part right here. I now know what the angle is. In radians, that's 0.33. Now I can find VR, simple enough, because I have a hypotenuse and I'm trying to find the adjacent, I know the angle.
So arc sine of 0.33?
We're not looking for the angle, so we're not using arc sine, just,
Just sine of 0.33 equals 1.41, or 1. Whatever that number is, divided by our unknown value.
yeah, well, that's, that was we'll just say it's sort of a mess there. I heard sine before. So
Yes.
sine of phi 1 is what?
Well, I plugged in 0.33 for phi 1 because we know that value.
Okay,
So I said sine of 0.33 equals 141.4, which I had a really hard time saying.
Wait,
alright, what is sine again? Flash back to the basics.
Okay. So opposite, and we're doing adjacent, so it's cosine. Oh,
Okay, or ultimately VR, it would be cosine, 141.4 times the cosine of 0.33 radians.
oh, alright.
that was even more of a mess than I realized.
I was no trick enough.
Flashing back to, you're basically breaking this up into components to connect it with first semester stuff.
133.8.
One 33.8.
Volts. Oh, ohms?
Yep, nope, you're right.
Volts, okay.
We could have also done it a little bit simpler, more simply. I know it's my maximum current times the resistance. So I could have also just done 2.68 times 50, which I hope is that.
Okay.
Wait, I have a
Yes, it
question
is.
about how we got this. So, we were looking for V sub r.
Yes,
So why did we do exactly the trig function that excluded V sub r from what we were solving for? Because it looks like we used the V sub c minus V sub l and we used 141.4, but we didn't even write V sub r.
right, because I was initially told sine, so I was working under what is sine.
Yeah,
What is
I-
sine actually gonna find us? That's
Right.
why I wrote that. And then when someone said it's cosine, that's when I switched over to, yes, it is cosine, and this is just the hypotenuse times the cosine of the angle.
Okay, I see it now.
Yeah,
They,
no,
right.
and something happened.
We didn't have to do all this because of these formulas, right? But
Right.
if you didn't give us the resistance, then we would have had to solve this way.
Yeah, yes. But if you didn't have resistance, then
You couldn't solve
you
for
couldn't have
X.
found impedance and.
Yeah. We would have been, yeah.
Alright, so V sub L, doing it the simpler way, 2.68 is my maximum current times X sub L. Not that far.
187.6.
Wait, why do we do X sub L and not just the 100 millihenries?
Because the relationship between the voltage and the current is
Oh,
with X sub
okay,
L.
with okay, gotcha.
Don't let the Henrys confuse you, Harris.
I wanna work with Henry.
And then V sub C, or what's the maximum value of the voltage going across the capacitor? Point what?
142.3.
And there we have our 8 equations.
Beautiful.
It is. I'm now about to do a potentially more complicated looking one, but I'm not gonna take you through all of this.
I wish on a test it was that easy. Not that that was easy, but like this was difficult, and then on a test, I'm like, what? And then, yeah. Like this took us a good amount of time, so on a test, if this was one problem, I'd be like, okay.
Yeah.
2 hours set aside for just one question.
A test with one question. 27 marks. Part 1, subsection A. Alright, I assume that I gave that gap there for people to ask questions, so I'm assuming there are no questions there.
It's something like so many questions that it just comes out to be a blur that feels like no questions.
Oh, I did have a quick question before you erase that. Why, can I come up here and point to it? 'Cause I'm
Yeah.
not